Today we're going to be looking at Unit 5, Similar Polygons. So we have 3 vocabulary words, so make sure you take a look at your vocabulary sheet for the definition of these words. We will be using them throughout the lesson. So we start off with a learn, so similar polygons. A dilation is a type of similarity transformation. A similarity transformation is a transformation composed of a dilation or a dilation and a rigid motion. So two figures are similar polygons if one can be obtained by the other or from the other by a dilation or a dilation with one or more rigid motions. Remember, rigid motions does not change the way the shape looks, the size of the shape. That's what dilation does. So let's go ahead and let's take a look at example 1. We have 2 theorems here, so similar polygons and properties of similarity. So we're going to take a look at example 1. It says using a similar statement. So we have A, B, C, D is similar. That's what this little squiggly right here means, is similar. So is similar to PQRS. List all pairs of congruent angles and write a proportion that relates the corresponding sides. So let's go ahead and start off with congruent angles. So our first pair of congruent angles is angle A is going to be congruent to angle P. Then we're going to have angle B is congruent to angle Q. Then we're going to have that angle C is congruent to angle R. And lastly, we're going to have that angle D is congruent to angle S. So if we look here, A is in the same spot as P. So what we did was we did a dilation and then we did a rotation. So now let's set up our proportions. So our first one is going to be that AB is connected with PQ. And this is going to be equal to BC is connected to QR. And what we're basically saying here is when we figure out what the side length of this is and the side length of this is, and we reduce it down, then like we had with our scale factor, these two are all going to be, or these four are all going to be equal to each other. So CD is connected to RS, and DA is connected to SP. So there is our proportion statement. So identify similar polygons to determine whether triangle NQP is similar to triangle RST. So we're going to start off with our angles. So let's start off with our angles. Well, if we notice here, we have angle N is congruent to angle R. So angle N is congruent to angle R. Then we have this double one, so that means that angle Q is congruent to angle S. So angle Q is congruent to angle S. Well, what about these last ones? Well, the last ones are actually going to be congruent too. So angle P is congruent to angle T, and this is by triangle sum theorem. What's triangle sum theorem? All 3 angles add up to 180. Well, if these angles are the same and these angles are the same, then when we add these 2 angles and subtract it from 180, we'll get P. Well, guess what? When we add these 2 and subtract from 180, it's going to give us T, and these 2 are also going to be the same. So next, we want to check their corresponding side lengths. So let's start off with NQ. So we're going to start off in the top is connected to RS. So that's our longest side length. So NQ is 12.5. RS is 10. and this reduces down to 5/4. Our next side length is QP and ST. So this is 11.5 over 9.2. These are our shortest sides, and this is going to reduce down to 5/4. And then our last one is PN, and this is TR. So PN is 15, TR is 12, so this is going to be 15/12, which is 5/4. So all three of these have the same sides, and all the angles are the same. So triangle NQP is similar to triangle RST, and our scale factor is 5/4. Let's take a look at example 3. So use similar figures to find the missing length. So this time, what we want to do is we want to solve for a missing length. So we know that the two are similar to each other. So we want to solve for what? Well, I have that WZ corresponds with PS. And I get that from here. WZ, PS. Okay. Equals YZ over RS. YZ, the last two, RS, the last two. So where they fall, that's where we know the corresponding. So X corresponds with Q. So plug in our numbers. So this is 16/12. Again, I'm getting that right over here from the figure. And then YZ is 5Y minus 2. RS is 6. Cross multiply. So this gives me 12 times 5y minus 2 equals 16 times 6. Distribute that. So that gives me 60y minus 24 equals 96 plus 24 gives me 60y equals 120. I'm going to write it over here because I'm running out of room down there. Divide by 60. Divide by 60. I get y equals 2. So that means that our scale factor, or sorry, not our scale factor, our y value for this is 2. So that means that the length of this would be 5 times 2 minus 2. So 10 minus 2, which is 8. So today we learned about similar polygons. So again, where they fall, the letter falls, that's where we have our corresponding sides along with our corresponding angles. And then we can find similarity by checking all of our angles and checking our side lengths. So go ahead and write a summary down here at the bottom.